Hello everyone, my name is Dinesh Saldar and I'm a physics as well as mathematics faculty. Today we are going to talk about the number system. So this is the topic I have chosen from your class 7th. Okay, so we will be talking about the number system today. Okay, so first the thing is why we require the number system, right? So this number system actually we called as language of mathematics. Okay, so why we call it is a language of mathematics, right? Because if we want to count or measure anything, we require numbers, right? Okay, the first thing is what this number system. This is to be called as language. Okay, this is our language of mathematics, right? Okay, language of mathematics. And why it is the language of mathematics, right? So what I told you, for why we call, because if we want to count something, right, or if we want to measure something, like if we want to measure the length, if we want to measure the height, we require number, right? So that's why we called as a language of mathematics. It has huge application, right? Suppose if we want to compare something, like which is smaller or which is bigger, right? Okay, so for that also we require number system for comparing, right? How we compare? Suppose we have two so suppose any kind of length is there, right? Suppose we have to book here, right? Okay, book here, another one book is there, right? So we can compare book 1 with the book 2, right? Okay, so how we can compare? We compare with respect to the length or with respect to the weight only, right? Okay, with respect to length as well as with respect to weight. Okay, suppose here if I consider this is weight is 10 kg, right? Okay, or the mass is 10 kg, right? And the second one is mass is suppose 4 kg. So how we compare? You know that, okay, 10 kg is more than a 4 kg, right? Okay, so like that we compare. Okay, and for comparing also we require number system. Not only for comparing, if we want to express any quantities, we require number system. For solving any kind of problem in science, okay, or engineering, okay, everywhere we require a number system, right? Not only that, in real life, suppose if we want to go to any grocery shop, okay, if we want to purchase something, right? So for giving the amount, we require number system. Suppose you have purchased something and the cost is suppose 231, suppose, okay, 231 is cost, and suppose you have given 250 rupees to the shopkeeper, right? Okay, so these are what? These are the basically number system only, right? So obviously that shopkeeper should return back to you the remaining amount, right? Okay, which is 19 rupees, right? These are all our basically related to the number system. So in our daily life, everywhere we require number system. Okay, so what we call basically this number system, basically we call the fundamental tool only. Okay, this is our fundamental tool. Okay, this is our fundamental tool in our daily life. Okay, which organized our life, daily life properly, or you can say that meaningful. Okay, so these are the use of the number system. So later on we will be talking about the natural number, right? Okay, so the first kind of number we have here, so natural number. So I hope you know the meaning of the natural number, right? So all the counting numbers are natural number, right? Okay, all counting number, okay, all counting, okay, all counting numbers only we called as natural numbers. Counting numbers only in the sense, suppose we can count 1 2 3 4 5 6 7 8, right? Okay, these all are natural number. And here what we are doing here, we are denoting the natural number on a number line, right? Okay, so we are denoting the natural numbers. Okay, the first number is 1, and in equally paced there is another one number 2, right? And again in equal pace, okay, there is another one number 3, right? Okay, then 4, then 5, okay, then 6 only, right? So the numbers are increasing, right? Okay, one by one the numbers are increasing, and see all the gaps are equal, right? Okay, and the line we have, this line basically we called as number line. Okay, this is your number line. So here what we are doing here, we are plotting the numbers on number lines, okay, and all the gaps will be equal only, okay. So this is our natural number. Now the next kind of numbers we have, that is we called as whole number. Whole number means what? 0 along with natural number we called as whole number, okay. Getting it? So 0 along with what, okay? 0 along with natural number, okay. 0 along with natural numbers, okay, we called as whole number. So obviously I hope you are understanding the same thing as we have learned before the last slide, okay. Natural number will be starting from 1 and it will be 2, 3, 4, 5, so on, and it will be goes up to infinity, right? The same case in case of whole number also, but it is starting from 0, right? Okay, it is starting from 0 only. So our first number will be 0, then 1, then 2, then 3, then 4, 5, 6, 7, 8, 9, 10, and so on. It can go up to infinity. And see here also we are plotting the numbers over the number lines, okay. And as you know that if we plot, okay, all the gaps will be equally paced only, no. So there will be equal gaps like this, okay. All the gaps will be equal, okay. So this is our natural whole numbers, right? Okay, so whole number basically nothing but 0 with the natural number, okay. 0 with the natural number we called as whole number. So these two are basic only, very basic, okay, the whole number as well as natural number. Next one is interesting because now we will be talking about the, okay, integers, right? Okay, so we have now integers, okay. So integers basically all the positive, negative number as well as 0, right, including 0, right? Okay, so integers is nothing but all positive numbers, right? Okay, all positive numbers, okay, all positive numbers and negative number, okay, including 0, okay, and negative number, okay, and negative number, okay, including 0, okay, including 0, and that is be called as integers, right? Okay, that means you see here we have all the positive number. Now only we have seen the counting number now, which is we called as natural number. So here we have all the positive number, okay, 1, 2, 3, 4, 5, right? Okay, these all are positive number, right? And there is a 0 also, okay, 0 also, and you see here -1, -2, -3, -4, -5, right? Okay, these all are our negative number, right? So what is happening here? See the left to right, okay, left to right the numbers are what? The numbers are ascending order, no? Correct only, no? The left to right, okay. If I talk about left to right, okay, so left to right you see here the numbers are in ascending order only, right? Okay, the number are in ascending order, okay, these are in ascending order. So obviously if I talk about the right to left, okay, right to left will be what? Descending order, right? Okay, so R I am writing in short for right and L in short for left only, okay. So right to left, these numbers are what? These numbers are in descending order, okay, they will be in descending order, okay, they are in descending order, okay, descending order. So I hope you are understanding, okay. So left to right it will be in ascending order, okay, and right to left it will be in descending order, okay. So this is the natural number. So natural number includes, okay, all the positive number, again I am repeating, okay, all the negative numbers along with the 0, right? Now the thing is what will happen, okay, if I add a positive number, okay, with a positive number, right? Okay, that means if I have a positive number, right, suppose I'm just giving you the example, suppose P is a positive number, Q also positive number, right? So if I add two positive numbers, the sum will be always positive, right? I hope you are understanding, right? So whenever we add two positive numbers, the result will be what? The result obtained, right, that will be positive. And obviously that will be what? Right to the given number, right? Okay, right to the given number means, suppose example, right, if I take a P is equal to 2 here, okay, just I'm taking the example here, okay? P is equal to 2. So with that P, if I want to, okay, if I want to add any number, right, okay, any number I'm adding, okay, any positive number we are adding here, right? Suppose if I want to add 1 here, so 2 plus 1 will be equal to what? 3 only, no? And the 3 will be what? The 3 will be the right to the given number, right, okay, right side only, no? 3 will be the, see here, the 3 is what? Right side of the given number 2, right, okay? So whenever we add a positive number along with a positive number, the result will be obtained, no? And that will be right to the given number, okay? So what we can say, here the result we obtained here, okay? Here the result will be what? Right, okay? The result will be right, okay, side of the given number, okay? Right side of the given number, okay? Understood? So right side of that given number only we will get the result. Okay. Similarly, what will happen if I add with a negative number? Add with a negative number. Suppose P is a given number. Now we are adding, right? Okay. We are adding a negative number, right? Okay. Suppose we are adding here 3 minus 3. So 2 plus minus 3, you know that 2 minus 3, right? Okay. If we subtract 2 from, okay, 3, no, what we get basically? We get here minus 1. I hope you understood, right? Okay. And see that a minus 3 is the result only, no? Minus 3 is your result. And where will be the result then? The result is right of the given number or left side of the given number. See, 2 is our given number, right? So whenever we are adding the negative number, see, our result is here only, no? Minus 1. That means you can see that when we add negative number, right? Okay, our result will be what? The result will be always left side of the given number. Understood? The result will be always in the left side of the given number. Now what will happen if I subtract a, okay, when a positive number will be subtracted, what will happen? Same thing only, no? Okay, suppose 2 is there and we are now subtracting, okay, we are now subtracting a positive number. Then we are subtracting 5 here. Just giving you the example, okay. So 2 minus 5 will be what? That is also minus 3. So in this case also the result is obtained here, no? So minus 3 is your result, right? Okay. And where will be the result? Where will be the result? It will be obviously left hand side, okay. It also will be the left side of the given number, right? Okay. Left side of the given number, okay. Left side of the given number, correct? So just before that one only, no, here also, no, just less, I'm not writing that, okay, because you are understanding, I hope you are understanding, okay. So in that case also same thing only, okay, left side of the given number. Now the thing is, what will happen if I subtract a negative number from a negative number, positive number. Now we want to subtract, right? Okay, so 2 is the given number. Now we want to subtract a negative number. Suppose the example is I'm taking here 4, I want to subtract, minus 4 I want to subtract here, right? Okay, so we are subtracting a negative number from a positive number. So as you know that since we have a minus, it will be plus only, so we'll get 2 plus 4, right? That means 6 only, right? And here the result will be what? Here the result will be right side of given number, okay? Right of the, or right side you can write, okay? Right of the given number, okay? Right side of the given number. So these are the basic properties you have to remember, right? So from here also you can say that sum of two positive number is always positive. Understood? When we are adding two positive number, it is always positive, right? Understood? Okay. So if I want to say in the next slide, okay, here we have a properties under the addition, right? Okay, so we can say the sum of two positive number is always positive, right? So first point, what we can say, sum of, okay, sum of two positive number, okay, sum of two positive numbers, okay, are always positive, okay, are always positive. Clear? sum of two positive number will be always positive. If we add 2 plus 3, 5, which is positive only. So any example you can take, okay, sum of two positive number will be always positive. So if I talk about sum of two negative number, then sum of two negative number will be always positive or negative. So just let us, okay, see that by using the example. Okay, so I will be giving you the example, right? Okay, so minus 2 is your negative number. With that, I'm adding minus 4 here, right? Okay, so what we get here, you know, the minus 2 minus 4 only. So minus we can take common. So 2 plus 4 only will be getting here, no? So 2 plus 4 actually what, 6 only, right? So minus 6, right? Okay, minus 6. Understood? So when we add two negative numbers, right? Okay, so when we add two negative numbers, so result will be always negative, right? Okay, so sum of two negative numbers is always negative, right? I'm not writing in sentence. I hope you understanding. If you want, I'll write and give you. Okay, sum of two negative numbers. Okay, sum of two negative numbers. Okay, always, okay, it will be always negative, right? Okay, always negative. But if I say sum of a positive and negative number, it may be positive, may be negative, may be 0 also, right? Okay, correct. Suppose if I add 3 with, okay, 3 with minus 2, so what will get? You'll get here 1. 3 minus 2 is 1. Or if I add 3 with minus 4, so 3 minus 4 is actually what? Minus 1, no? Correct? That means sum of a positive and negative number, it can be positive or it can be negative. Okay, understood? It may be positive, may be negative. So you cannot say that sum of a positive and negative number is always positive. That word you cannot say. Okay, so it can be either positive or either negative. Okay, I hope you understood the basic, right? Okay, now we will be talking about the other properties also, right? Okay, other properties means like the additive properties. Okay, then the closure properties we will see. Okay, then we'll see the commutative properties, we will be seeing that associative properties, all those things. Okay, so first property here we will be seeing that, and that is your, okay, that is your additive property. Okay, very simple thing. Okay, just let me tell you that. Okay, so first one E only I'm writing here. Okay, so this will be your additive property. I'm writing here E only. Okay, so now we are seeing some properties. The first one is your additive properties. Okay, additive properties. So what is the meaning of the additive properties or additive inverse we say? Okay, additive inverse. So what is the meaning of the additive inverse? You know that if I have a positive number, with that if I want to, okay, subtract with same magnitude but negative number, what I'm trying to say here, suppose 2 is a positive number, right? With that, if I want to add minus 2, now what will get? Will get 0 here, right? So when sum of two integers add 0, both are integer only, no? When sum of two integers are 0, then one integer can be called as the additive inverse of other. Understood? Okay, so here you see here sum of two integer is 0 only, right? Okay, sum of two integers here 0. So any of the integers, 2 will be what? 2 will be the additive inverse of minus 2. Or you can say that minus 2 is the additive inverse of 2. Okay, you can say that way. Okay, so this is your additive inverse. Now there will be another one property, that is we called as closure property. Okay, that is we called as closure property, right? Okay, but see here we are talking about what? Addition only. Okay, we are talking about addition. Closure property, what it says? It says that if I have two integers, so their sum also will be always integer, which is obvious, right? Okay, suppose if I have an integer p and there is integer q, so if I add two integers, that also will be always integers. Okay, any two integers if we add, that will be always integers. So obvious property, these are the properties, this kind of properties we called as closure property. Okay, So p is an integer, q also integer, and their sum also will be always integer, right? Then there will be another one property that is we called as commutative property. Okay, that is your commutative property. So commutative property means what? If I want to add p plus q, that will be equal to what? Q plus p. Okay. Example, if I want to take this kind of properties we called as commutative property, right? You just give me a little example, right? Okay. You can construct the example. Okay. It's not like that. What example I'm writing here, you should follow that. Okay. By understanding the concept, okay, you have to construct the example. Okay. So just I'm giving you the example. Suppose minus 2, right? Okay. Plus 4. So similarly, if I write 4 plus minus 2, both are acting same thing only, you know. So minus 2 plus 4 means what? 2 only, right? So 2 plus 4 plus minus 2 also 2, right? So this kind of properties we called as commutative properties, right? So addition is actually the following the commutative properties. There will be another one property also, and that is we called as associative property. Okay, the D1, D. Okay, this is your associative property. Okay, associative property. Now in case of associative properties, whenever we do no, so we take three variables here. Okay, so I'm taking here p, q, r, right? Okay, so we can say that p plus q. So first we are doing the operation between p and q, along then we are doing with r. That will be equal to what? P plus q plus r. Okay, this kind of property we called as associative property, and it always follows, right? Okay, our integers are there. Okay, it will always follows the associative properties under addition, right? See, what are the properties I'm saying here? I'm talking about under addition only. Okay, okay, so it will follow the, okay, it will follow the associative properties. You can take example, right? Okay, example, any three numbers you choose it. Okay, any three numbers. If you don't want to choose negative, no problem. If you want to choose only positive, choose positive, right? Okay, suppose we have 3, 4, 5, right? Okay, so what we'll write here? 3 plus 4 plus 5. So first we'll do the operation between 3 and 4, 7 plus 5, right? 12 only, right? Similarly, if I write 3, okay, plus, okay, then we have 4 plus 5. So first we'll do the operation between 4 and 5. So 4 plus 5 is 9. Along with that 3 is 12 only. So both sides it is satisfying, right? Okay, this kind of property we called as associative property. There is another one property. Since I don't have this, so I will be writing here. Okay, I will be writing here E here. Okay, E we called as additive identity. Okay, this is we called as additive identity. Okay, additive identity. Okay, additive identity. Since I don't have space here, okay, so I'm just writing in conjectured way. Okay, so additive identity. So the meaning of the additive identity, in case of addition, no, 0 we called as additive identity. Why 0 is the additive identity? Because with 0, if you want to add any number, you will get the same number only, right? Okay, 0 you want to add or you want to subtract any number, you will get the same number only, right? Okay, so 0 adding with 10 here, right? Okay, so these are the things we are talking about addition only. Okay, not for subtraction. So I'm only doing the addition. Okay, understood? Okay, so 0 plus 10 also is your 10 only, right? So if I want to add negative number also, so 0 with minus 2 also will be what? That also will be minus 2. So if you want to add any integers along with 0, what will get? The same integer, right? That's why this 0 we called as additive okay, identity. I hope you understood the, okay, properties on integers, right? Okay, based on what? Based on or under addition, right? So in the later class we will be talking about the subtraction as well as, okay, multiplication and division. Thank you everyone. Thank you for watching this. Thank you so much.